Okay, so up next we have Harmony Protocol, Ganesha.
Hey, John, can you hear me?
I can hear you just fine. How are you?
Good, good. How are you?
Doing fabulously. So you're going to talk about cross-chain applications.
Yep.
Cool. Are you ready?
Yeah, I'm ready.
All right, take it away.
Sure. Hello, ETHDenver. This is Ganesh from Harmony. Let me share my slides. Okay. You see my slides, right?
Yes, we do.
Okay. Hi, this is Ganesh from Harmony. I'm an engineer. I work on building cross-chain infrastructure for Harmony, specifically something like a bridges and light clients and so on. So in this workshop, I'm going to actually port an Ethereum application to Harmony, and that has some cross-chain aspects to it. So here is the outline. I'm going to first describe Harmony in just one slide, and then tell you about what is Harmony for Ethereum. And then get into the demo of porting an Ethereum application to Harmony. And then if time permits, we will talk about some of the more cool stuff. So after this slide, I only have 2 more slides, okay? In one slide, Harmony is a layer 1 blockchain, just like many layer 1 blockchains, Ethereum, Near, and so on. And Harmony has a 2-second block time, and it also has 2-second transaction finality. And it's a decentralized network of nearly 1,000 nodes, and it follows a traditional Byzantine consensus, slightly optimized. And Harmony is a sharded blockchain with currently 4 shards with 250 nodes each with the uniform security. And Harmony is also based on proof of stake. Yeah, that's about Harmony. So what is Harmony for Ethereum? I'd like to describe this as a journey represented by these 4 blocks you see. I would like to call this as a journey because we initially started with a fast and cheap blockchain that has a full EVM compatibility. We initially thought this was enough, but it turns out when developers try to port their application from, let's say, Ethereum to Harmony, they needed something to also bring their assets from Ethereum to Harmony. So that required us to build a cross-chain infrastructure with bridges. Was that enough? No. Developers, although they like to use new tools and like to learn new libraries and so on, they wish whatever works on Ethereum side is also seamlessly work on Harmony. So there comes the Ethereum tooling compatibility. So Harmony, recently we were able to achieve full Ethereum compatibility in terms of tooling, meaning that tools like MetaMask, Web3.js, Ether.js, and all those fantastic tools work on Harmony. So if you would like to read more about these 4 pillars, you can find some Medium articles here. I will share the slides after my presentation as well. So you may think Ethereum tooling compatibility, what is the big issue, right? Harmony being a sharded blockchain, its transaction structure differs from a non-sharded blockchain. So that creates a lot of complexity for making these tools really compatible. So that's why it's a big deal for a sharded blockchain. So with that, let's get right into the demo, where I will try to port an Ethereum application to Harmony. So let me go here. My screen is still shared, right?
Correct.
Okay. So I was wondering what is the right application I should pick to port. And there is no best place other than ETHDenver itself. I went through the last year ETHDenver submissions. There's a lot of really cool submissions. Developers have put their blood, sweat, and tears in achieving in a short period of time. So I would like to say this is kind of a tribute to the developer efforts. So in these wonderful set of applications that were built in last year hackathon, I came across this Lend 721 or Lend NFT application. I found this very interesting. So let's go ahead and open this application. So thanks to this developer for providing such a wonderful application. This application is basically a NFT lending platform where lenders can lend their NFTs, ERC-721s, and they can earn some interest in some other fungible tokens. Specifically, this platform uses DAI as a token where the lender will earn the interest. Borrowers can collateralize their DAIs and lend the NFTs from lenders and use it for other purpose. So why I picked this application is that this is simple enough for me to code, as well as this has both fungible and non-fungible assets. And both of these fungible and non-fungible assets exist in Ethereum, so I can use cross-chain element to bring them to harmony and really show the application. So this was an application that was built in the last year hackathon, but recently in the past 10 days, there were some activities. So it's also deployed on Ethereum mainnet. So let's go ahead and open this mainnet contract here. So let me maximize slightly. So let me go ahead and look at recent 2 transactions here, right? So here is the one. And what we notice is this is a transaction to basically lend or create a lend request. So with the 99 GWay gas price, it took nearly $50. So if we go ahead and look at now, it will cost even more. So really use this application, people like lender and borrower have to pay a lot of gas fee. Similarly, let's look at this transaction. This is a remove lending. Again, you have to pay a lot. So just keep this in mind when we see what happens when this runs on Harmony. Right? So let me close this. Okay, so to begin, let's go ahead and clone this application. So I'm going to go open my terminal here. I'm going to do git clone lend 721 and then go inside this directory. So to save some time, I ran through this demo once and I collected all my changes that I did into a patch. So I'm going to do git apply my patch cart lend changes. And I am going to explain the changes I needed to make to get this working on the Harmony blockchain. So I applied my change to. I don't want you guys wait for the build of this application, so I'm going to build this once. Okay, let me just open this application. While it is building, I can also explain a little bit. So let me do npm install. So what is this application really? It basically has a smart contract and I'm in the version 1, version 2, and mainly to handle the NFT lending. And it also comes with a nice client that I'll show in a bit. While this is installing, what is the first step I needed to do? To make this, the first step is to deploy this NFT 721, ERC 721 lending smart contract. So let's go ahead and look at truffle config here. So it initially had the development and some networks added to it. So the first step is I need to go ahead and add Harmony network. So as you guys are familiar, the truffle, you basically add the network ID and also point to the correct network URL, node URL, and some other bunch of stuff you need to specify to add a new network. So for Harmony, you can find one way to get the truffle working for Harmony. And another way is use the truffle provider that is available in Harmony.js SDK. So I'm also using defining a configuration for that. It is also very similar. So network ID of one. So this application I'm going to deploy it to mainnet directly. I'm not going to use on testnet. So everything is going to be on mainnet. This is the truffle provider of Harmony.js configuration that is required. So squared, its initial npm install takes some time. Meanwhile, what I can do is in this application, you guys saw I need to have two kinds of asset, right? ERC721 and also a DAI. So let's go ahead and see how we can get those, right? So Harmony, we have a bridge to Ethereum, one instance running on the mainnet and another instance running on the testnet. To save some time, I already bridged two assets. Let me go ahead and click my transaction. I bridged DAI from Ethereum to Harmony. So yeah, this loading of these links may take some time because I'm also live streaming. So this is the DAI that exists on Ethereum, and there's a one DAI that exists on Harmony. Yeah. So, and I also needed a NFT or ERC721. So what I did was I purchased a Nifty Gateway NFT and I bridged to Harmony. So this exists on both Harmony and Ethereum. So quickly, this is a Harmony to Ethereum bridge, which you can use to send any different kinds of assets like ERC20s, stable coins, and you can send Harmony native tokens like HRC20 and one token to the Ethereum side. And also this bridge allows you to bridge NFTs like ERC721 and also the native ETH. Let's see if this is complete. Yeah. So next step is we have to deploy the lending smart contract, right? So for that, I also need some configuration environment, basically. So I'm going to just simply copy the environment here. Let's do truffle migrate. I'm going to use Harmony truffle provider. Hopefully, let's see if it works. Okay, it's compiled. It's migrating. Shouldn't take more than a few seconds. Yeah, few more seconds. Starting the migration. So what happens is after we deploy the contract, we have to initialize the lending contract with the fungible asset that will be used as a collateral. So in this case, it will be DAI. So the contract is deployed, and this is the fungible asset that exists on, it's a DAI on Harmony that we recently built. So you can go ahead and check this one. Okay. So if I go to the Explorer of Harmony and put that address, you see that it's a DAI stablecoin that was recently bridged to Harmony. So once we do that, now the contract is deployed. As I mentioned, this project came up with a nice client, which we are going to npm install here once. This should be pretty quick. So what I'm going to do is initially show the application and then show the changes that I had to make in terms of the source code. This should be very quick. Get some water for me. So I have about 13 minutes. So yeah, hopefully this will be enough. So while this is happening, okay, let's see. It should be. Almost there. Okay. Let's see. Yeah, we're good. So I'm going to do yarn build once and then start the application. It will come as a browser application. Okay. We're good to go. Let's do yarn start. So it's hosted in localhost 3000. Yeah, here is the application. So it's automatically connected to MetaMask, and it is showing a nice looking NFT. So in the MetaMask, I have two accounts. One is the lender and another one is a borrower. So this lender, you can see that added a Harmony mainnet configuration. You can actually go ahead and look at that once. It's pretty straightforward. Harmony works on MetaMask right out of the box. You just add network, URL, and chain ID. That's sufficient. So this lender, you can see, has one NFT. You can also look at this NFT in the Harmony One wallet. I have the same lender under HRC 721. You can see this NFT. Okay, so the lender has this NFT and now he wants to lend this NFT. So I'm going to click on this lend and I need to approve. So MetaMask transaction, confirm. And let's keep an eye on what's happening here. So after this approve, it's going to ask me to set some of the lending configuration. Yeah, so I'm going to set, let's say 10 DAI as an initial token worth, and I'm going to keep it, let's say 1 hour. And I'm interested in earning 3 DAI from the borrowers. So I'm very, it's an expensive one, but still let's go ahead and confirm. Okay, a little bit slow. Let's confirm. I think I popped up 3 transactions here, but okay. We can reject the others. That's fine. Okay, so I was able to successfully lend. Let me reject the other things that okay. So you can go and see this set lending transaction on Harmony blockchain. You can see how much it costed, right? It's really very low transaction fees. When compared to earlier, I showed how much it costed in Ethereum, around $50. So I can go and application still has some glitches. So I can see that I already have lended one NFT. So now let's go ahead and change the account here to borrower. So I have several accounts here. Meanwhile, you can also go ahead and check whether the lender still owns the NFT. No, he doesn't have any NFT now. So it's lended. So let me go ahead and refresh this screen here. So this is a borrower. So now I can see that a borrower it's available for some borrower to borrow. So I'm going to borrow. The configuration is loaded automatically. So I'm going to allow. Okay. Okay. Similarly, you can go ahead and check. The transactions are pretty cheap to run on here. So let me go back. Here I had to, initially, it's a multiple transaction. Initially I had to approve for borrowing and then do the actual borrowing. So this is one more transaction. Okay, so now I can see that I have borrowed. And I can also check here that in my borrower assets, I have this NFT and also go to the one wallet and change to borrower and look at the HRC 721. Yes, I have the NFT borrowed. So now let's go ahead and change the account here to the lender and refresh this page. Yeah, in my land, I can see that somebody has already borrowed my NFT and they are paying me 3 DAI. And there's also a nice message that if a borrower doesn't return the NFT, I can claim the whole collateral. So let's go ahead and change this to borrower again. And 5 minutes to go, should be enough. In my borrow, I am going to cancel borrowing, allow transfer, confirm. So I'm basically returning the NFT that I borrowed, and I should get charged with 3 DAI in return. So that will be paid to the lender. So in the front end here, you see it takes some time. It's basically the front end logic. The transaction itself is executed in 2 seconds, and it's pretty fast. So just keep an eye on here. I should get back my DAI. So you see, yeah, here you go. I received my 10 DAI back, and if I go to the lender, here I see 3 DAI I earned. So that is a demo. We have 5 minutes. I'm going to go to the code here. So, and explain what else I changed to make this work, right? That is interesting as well. So these are the simple migration truffle stuff I needed needed to write to deploy the NFT lending contract. Apart from that, I also changed the client a little bit. So what did I change is basically here. Let's see in the collectible. Okay. Yeah. What happens here is that this particular client refers to the OpenSea where this particular NFT was hosted. If I go back here, you can look. The NFT was hosted in the OpenSea. If OpenSea was deployed on Harmony, we basically have to change nothing in this whole application. Since it was not deployed, now I need a way to really map that NFT. For that purpose, I used when I bridge the NFT from Ethereum to Harmony, what I do is I give my NFT to a bridge smart contract on the Ethereum side. So that is what I am referring here. Find the collectibles of the lender in the bridge smart contract on the Ethereum side. And after that, find the mapping of the particular NFT. So if you see here, this is the contract address and this is a token ID for this NFT. This contract address does not exist on the Harmony network. So let's go ahead and see what is the mapping for that address. So if I type here the Ethereum address, you can see that when I bridged my NFT, it was given one Harmony NFT address. So that's exactly what I'm doing. I'm trying to find the mapping using the bridge for that particular NFT. So once I find the mapping, I can filter whatever in the lender page you see here, right? So if I go ahead and change this one, okay, this is on the lender. So refresh. Okay, I should cancel and then I will get back my NFT. So meanwhile, what else did I need to change is simply add one more function that will filter the NFT based on whatever I want. So with these three functions, basically that's it. So if OpenSea, which is an NFT marketplace, is deployed on Harmony, let's say, then I basically don't have to do any of these changes. Then I'll be able to look up the NFT in the OpenSea and able to get all the information regarding that NFT. So yeah. So for the lender, I see the NFT is given back. So that is all I needed to change in terms of the code. So let me go back to my slides. So I have 2 minutes going to quickly different approach to when we bridged Ethereum. Basically, we wanted to get a bridge working on the mainnet and then slowly improve the trustless factor of the bridge. Initial deployed bridge contain a set of validators who will attest the cross-chain events. Basically, when a user wants to bridge an NFT or a ERC20, they will ask this valid bridge to perform the locking of the token on the Ethereum side. And after a sufficient number of confirmations, the bridge validators are going to perform the minting on the Harmony side. In the similar fashion, for returning the bridge token back to Ethereum, the user will request the validators to burn the bridge token, and they are going to unlock on the Ethereum side. So we currently working on migrating from the validators network to a completely on-chain verification-based bridge. You can read more information here. And I'm going to skip to my final 2 slides here. Gentle reminder that there's another talk by our CEO, Stephen. If you'd like to know more about Harmony and what are some of the exciting stuff that's happening this year, please tune in to that talk. And we also have some bounties, specifically 5 of them worth $2,000 each. Basically, we want you to build applications that utilizes the bridge, and one more project from the list of sponsors. If you include more than one sponsor, then you are going to earn more bonus points. And that's it. Thank you for taking time. Come build on top of Harmony. Very excited for this opportunity.
Thanks, Ganesh. It's good seeing you. Thank you for the wonderful presentation.
Thank you. Bye-bye.